So we have negative 1 comma 3 and 2 comma 5. And I'm asking you guys to add the vectors. So again, just like I said in the last one, we're going to be graphing these. Negative 1, 1, 2, 3. That's vector u. And then w is 1, 2, and then up 5. 1, 2, 3, 4, 5. Does everybody see how I plotted these? Okay? And again, I'm only doing this for instructional purposes. I will still do that number 17, so we'll go and see. But I want you guys to kind of visually represent. Basically, what we're doing here is when we're adding vectors, you're taking one vector and adding them, right? When you add numbers, you put 2 plus 3. You're combining them together. So we're combining these two vectors. Now, if I was going to ask you, 2 plus 3 is the same thing as 3 plus 2. Would you guys agree with me? 2 plus 3 is the same as 3 plus 2. So it doesn't matter if I put w on top of u, or if I put u on top of w. Either way, they're taking us to the same terminal point. Would you guys agree? Right? So vector addition is what we say. It doesn't matter which order you do it. So in reality, what are we really doing with vector addition? We're really combining the first components, and we're combining the second components. So we could say this is u1, that's u2. This would be w1, and that's w2. So when we're doing vector addition, all you're simply doing is adding the first component and then adding the second components. OK? So therefore, we get, let's see, this becomes negative 1 plus 2. And this becomes 3 plus 5. So our resultant vector is 1 comma 8. And let's see how close I did by sketching this. So over 1, up 8. 1, 2, 3, 4, 5, 6, 7, 8. So that blue vector is now what we call our resultant vector. Does that make sense? I didn't have time last class period to go over this. So that's why, Cameron, I'm spending the time a little bit today so you guys can see that vector addition.